Good morning, students. Today we'll learn more about the the more next exercise we have with new method in class 12th maths, that is in chapter integrals. So now let us find more methods of integration. Now that yesterday we have started this topic. This topic is so vast. So now let us move to the methods of integration. We have methods of integration. Okay, so first we have integration. First we have integration by substitution. Okay, second one, integration by partial fraction, and third topic we have integration by parts. So we have here three methods of integration. Let us discuss them with examples one by one. So my first method is integration by substitution. We'll discuss these three methods one by one, and let us see how we able to solve these numerical by using such kind of methods. Now let us take some examples here how we will apply the method of substitution. Okay, first example I have. Now I am taking one example, that is sine mx dx. With respect to dx we have to integrate. What we can do, put mx is equal to t, so that we got m dx is equal to dt. We all know that m is a constant term, so we will put aside and will try to differentiate x with respect to dx, that we got only 1. So dx is equal to dt. Now we'll put here value, that is sin t dt. Okay, we have put this value, so we'll get this sin t dt. Now we can easily integrate cos t plus c, that is, now I can put a value where t is cos mx plus c. Okay, so that is how we can apply the method. Let us try to solve more complex questions so that we are able to learn about this method very easily. Let us try to solve one more example I have. 2x sine x square plus 1 dx. So now what we can do, 2x sine x square plus 1 dx. So now we'll try to sort it out how we can easily solve this. Now we have 2x sine x square plus 1 dx. Now here we need to solve this numerical with the help of the method, that is substitution. Let us see how. Put x square plus 1 is equal to t. So what I got, 2x dx is equal to dt. So I got x dx is equal to dt by 2. Okay, so now I can put the value here. What I got is, I have to put outside because 2 is constant. So now if I put 2 outside, now x dx is equal to dt upon 2. So I will take 2 outside. Okay, and here I put only sin t dt. Okay, now what I got, minus cos t plus c. We all know the integration for the formula which we have learned yesterday. Okay, so now minus cos t plus c. What is t here? What I have taken the t here? X square plus 1 plus 3. Okay, so that is how we can solve this numerical. Okay, let us try to solve more numerical so that we will be clear with this method. Now let us move to the third question now. We'll move to the third example now. Let us see what they have given. Now the third is, we have in this example, that is 10 raised to the power 4 root x sec square root x upon we have root x. Now this we need to integrate with respect to dx. Now this is given and we need to apply the method. Okay, so now let us try to solve this method by using the method of substitution. Now let us try to solve this using the substitution method. Put root x is equal to t, so I got the differentiation of this will be root x dx is equal to dt here. So I will put here 10 raised to the power 4 t sec square t, and this will be 2 I will kept here, so I will got dt. And now I will do another substitution here. Put what I will do, tan t is equal to u, so that sec square t dt is equal to du. So I got u4 du with respect to this. Now what I will get here is u5 upon 5 into 2 plus c. So now 2 upon 5 here. What is u? I have taken the tan t plus c. Now what is the value of t here? So I will get 10 raised to the power 5 root x. Okay, so that is how we are able to solve such kind of numerical. Now let us move to another one. Okay, so the next one we have, that is sine inverse, that is next now we'll try, that is sine tan inverse x upon 1 plus x square. Now how to do? Let us try to put tan inverse x is equal to t. Okay, so now tan inverse x is equal to t, will differentiate it, so I will get dx is equal to dt. So now what will happen? Sin t dt. Now we all know the integration of sin t, that is minus cos t plus c, and what is t I have put? Tan inverse x plus c. Okay, I hope now we are clear with this method of integration by substitution. Now let us see, we have few more formulas. Likewise we have done previously in previous exercise. In this method also we have few formulas and we can prove them also. Okay, so now we have the formulas. Let us see how we can do it. Like we have important formulas which will be applied in the exercise, that is we have tan x dx is equal to log sec x plus c. First formula we have now here. This is a first formula, that is tan x is equal to log sec x plus c. How? Let us prove. Here what we can do, put, no, before putting, let us try to solve. We can write tan x is equal to sin x cos x dx. Now put cos x, okay, is equal to t. Okay, so what will happen? Minus sin x dx is equal to dt. So what will happen? Here we'll try to solve this. We'll get dt upon t. Now if I integrate, I got what I got here is, that is log t plus c. Okay. Now what is t? I have put cos x plus c. What I put here is 1 by t is log t. I have put log cos x plus c. Now this is negative sign. What we'll do? We'll take it to log sec x plus c. Okay. So now we can easily sort it out the formula. So we have got this formula log sec x plus c, that is tan x. So likewise we can find or prove other formulas also. Now let us move to second. Okay, let us move to the second one. Second formula we have cot x. We have cot x. We have to differentiate it. What I will get here? Log sin x. Log sin x. Okay. What we can do here? We can write cot x, that is cos x upon sin x. Cos x upon sin x. How the substitution works here? Put sin x is equal to t. So we'll got cos x dx is equal to dt. So what I got here? dt. What I have put? Upon t. So I will got log t plus c. So what I got here? Log sin x plus c. Okay. So that is how we can easily prove such kind of formulas. So we have now two formulas here. Now let us move to the third formula, which will be applied in the numerical, that is sec x. Now if I need to differentiate sec x, what I will get here? Log sec x plus tan x plus c. Okay, this is what we have. So now sec x we have log sec x plus tan x. Similarly, we have d, that is cosec x dx. If I need to differentiate it, I got log cosec x minus cot x plus c. Okay. So likewise, we can easily, use this method. Using this method in these formulas. Now these formulas will be used in the exercise. Let us try to solve numericals based on these formulas. Okay. So now let us try the questions. Now we have first question. Okay. Let us see by this method. We try to solve the questions. Now what is given in this is log x upon x. The first question we have log x upon x. We need to solve it with the method of substitution. Now how we can do is put log x is equal to t. So what I will get? 1 upon x dx is equal to dt. So what I got here? T square dt. So now let's differentiate it. I got t cube plus c. So I got, what I got here is t. What is t? Log x whole cube upon 3 plus c. Okay. So that is how we able to solve the numerical. put x4 is equal to t. So what we can do here is, so put this is equal to t. So what I got here is 4x cube dx is equal to dt. Now what we can do here is take 4 below, and I got sine tan inverse t upon what? If I have taken this 1 plus x8 dt. Now what will happen is tan inverse t 1 plus x8 we have here, but we have put the x4. Okay, x4 is the t, so I can take here, that is 1 plus t square. Okay, so now because its square will be t square, so now what we can do, we will try next substitution, that is put tan inverse t is equal to u, so that 1 upon 1 plus t square dt is equal to du. So now sin u I got here. Okay, I got here sin u, and what I got here is sin u du. Now we'll got the answer here, that is the integration of sin u will be cos u. So I will got here cos u plus c, but we'll now put cos u. What is u? I have taken, that is tan inverse t plus c, but what is cos tan inverse t? What is t here? T here is, what is t? I have put x4. x4 plus c. Okay, so likewise we able to solve such kind of numerical. Now let us solve two more. So now we have the next numerical. We'll try to solve the next numerical we have, that is this. Okay, now let us try to solve this one, cos root x upon root x. So now how to solve this? Let us try this. Put root x is equal to t, so that what will happen? 1 by 2 root x dx is equal to dt. Okay, so now what will have? 1 upon root x dx is equal to dt. So what will happen? 1 upon 2 will be outside, so I got cos t plus c. Now to cos t, what is t here? We have taken, so what is the integration of cos t? Sin t. Sin t plus c. Okay, so we have 2 sin, what is t here? Root x plus c. So that is how we are able to solve such kind of numerical. Now let us try to solve. Okay, so now we have the next numerical, that is x plus 1 x plus log x whole square upon x. So now let us see how I can solve such kind of numerical. Now we have, that is, we can take like this, x here and x plus log x. Okay, so I can divide here like this. Now 1 plus 1 upon x. Now we'll take x plus log x whole square with respect to dx. Okay, So now we'll try to see what we can do here is put x plus log x is equal to t, so that 1 plus 1 upon x dx is equal to dt. So what I got here is put dx dt, so I got t square dt. So what I got by integrating t cube by 3 plus c. So what is t cube here? What is t we have taken? T we have taken x plus log x. So I got x plus log x upon 3 cube we have, no? But only till here, okay? Okay, so that is how we able to solve such kind of numericals. Okay, so I hope it's clear to you. We have discussed today, that is the method of integration. The first method we have taken the method by substitution, method of integration by substitution. So we'll discuss now the next method. Okay, so